Hello everyone, welcome to ashatech.com, your engineering sciences channel. Now some of you have been asking me to share with you my videos for differentiation and integration. In this particular discussion, we are going to begin with the differentiation and its application. We have a guiding question which says, from first principles, show that d of the x of tan of x is equal to sec squared x. So we are differentiating a tangent of x with respect to x, and you want to show that it is equal to sec squared x. To begin with, on the solution of this particular problem, let us say let now y equal to tan of x, so that at the end of the day we find the y, the x. So to show how this is changing with respect to x, we can introduce small changes in y and also a small change in x, so that we have y plus delta y, which is a small change in y, is equal to tan of x plus a small change in x. So what happens is that I'm always interested in sigma y. This sigma y or delta y, whatever case you may call it, for me I will call it delta y, is what we are always interested in. Therefore, delta y, we are going to make it the subject of the formula to become tan of x plus delta x minus y, but we know y is tan of x. So we proceed. We can either expand the tan of x using compound angle method, or we can express a tan of this expression in terms of sine and cos. Let us take sine and cos for simplicity purpose. So delta y is equal to sine of x plus delta x divided by cos of x plus delta x minus sine x out of cos x. What does this mean? I can look for the LCM of this expression, and the LCM is cos will be cos x plus delta x times cos x. So I bring it here, divide by this, I will have cos x times sine x delta x, then minus sine of x into, of course, cos of x delta. Remember, this is delta y. So if I look at this expression closely, it must have come out of expansion of a compound angle using a sine. So let us, for example, say sine of a minus b. Sine of a minus b is equal to sine a cos b minus sine b cos a. Now if we, for example, assume that this a is equal to x plus delta x and b is equal to x, like we are seeing it here, it means I can say this is cos x, then this is sine of x plus delta x, then minus sine b, which is x, it becomes sine x, then cos a, which is x plus delta x, and therefore it brings us to this expression, meaning I can comfortably say delta y is equal to sine of x plus delta x minus, now divided by, of course, cos x times cos x plus delta x. What does that mean? Delta y is equal to this, and that will go out and they will cancel, so we remain with sine delta x divided by cos x cos into x plus delta x. We know for smaller angles, sine delta x is approximately equal to delta x, like it is always the same case with the tan of delta x. For smaller angles, it is also equal to delta x. Now we substitute that in our expression, so that we have delta y equal to sine delta x, of course, which we are calling, which we are going to call delta x, okay, then divided by cos x plus delta x. This is the same as delta x out of cos x, then cos x plus delta x, because this sine delta x has become delta x. Now I can divide both sides by delta x, so that I have delta y out of delta x equal to 1 out of cos x times cos of x plus delta x. What does this mean? I can now take the limit as delta x tends to 0. As it becomes so small and tends to be 0, then delta y, delta x will become dy dx, and this will equal to 1 out of cos x times cos x, because now this delta x has tended to 0, so we can substitute its value with a very small value close to 0. So this will cease to be delta x, and I mean cos x plus delta x, and you will approximate to cos. So dy dx will equal to 1 out of cos squared x, which is equal to sec squared x. Therefore, what we are asked, that we show that d by dx of tan of x equal to sec squared x. Since the right hand side is equal to the left hand side, then we are right. Thank you so much.